Assalamu alaikum. So the lesson today is about one of the most used application of addition. As you see, I didn't put the title yet, so I want you to discover the title by yourself. So let's start, and let's suppose I have a piece of paper and I want to create a small sheet of that piece without cutting any piece of that paper. I don't want to use the cutting process. So which process I'm going to use here in order for me to create those small sheet? So I'm going to use the folding process. So I'm going to use the process of folding. The first thing I need to do here, I need to fold this one into two equal pieces. So I'm going to draw a line to show where the folding occur. So that's the first steps I need to do. So fold into two sheets, for example. My second process, so we'll fold each sheet into two equal pieces. So I will fold the first one and I will fold the second one. So in the second folding process, so we fold each piece into two equal sheets. Each piece into two equal sheets or two sheets. Again, I keep folding each piece into two equal sheets. So I will have here two, here I will have two, here two, and here two. Again, I keep going, I keep folding again. I have 8 pieces now, so I want to fold each pieces into 3 equal pieces. So I'm gonna fold each one into 3 equal pieces. So now I have 3 pieces in each one here. So here I have total 8 pieces, and each one has 3 equal pieces. And if I want to know how many total pieces I have, so here I have 3 here we have 3, and here we have 3, and here we have 3, here we have 3, here we have 3, here we have 3, and here we have 3. So if I want to find out how many total pieces I have, I just need to add all of those 3. So when we add them, I got 24 pieces. And keep in mind, I have 8 of 3. So that's mean I have 8. The total big pieces are 8. So I have 1, 2, 3, 4, 5, 5, 6, 7, 8. So I have 8 of 3. So it's exactly what we have here. Now my question to you is, how many processes of folding we did? We didn't do 1, we did 2, we did more than 2. So if we did more than 2, so what we call that, there's a word we use for more than 2. So either many or multi process of folding. That's exactly what we did in order for us to get that number. So we did multi-process of folding in order for us to get 24. But there's something, or there's a word which is combine those two into one word. So which word combine those two into one word to express process of folding? So the only word who combine those two into one word is plicate or plication. The process of folding means plication. So if I substitute those two words with that word, so I will have multiplication. So and if we take off that minus sign here, so what we did here, we did a multiplication. And the lesson today is multiplication. So welcome to Crack Mathematics. So the lesson 7 today is about multiplication. Using the example we did in the introduction, so we sum 8 trees. So we got 3 plus 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 3, and we got 24. So we got 8 of trees. So what's the common between those trees beside similarity? So what is the common between those three besides similarities? What do you think? They are identical. So the terms of this addition are identical. So the terms of the above addition are identical. Or you can use like each other. Unlike. So what about the number of terms? Can we count the number of terms? Yes, the number of terms are countable. So this is the second property about this addition. So it has countable terms. And we know it's 8. If we count 1, 2, 3, 4, 5, 6, 7, 8, so we have 8 terms of that addition. So if I want to find the sum of 10 terms of 3, so what I will do here, so I will create the sum of 10 terms, I add them, then I will get 30. Now if I want to find out the sum of 40 terms of trees, so what I will do here, I will create the sum of 40 terms and I add them, then I will get 120, sorry. Again, if I want to create the sum of 100 terms of trees, so what I will do here again, I will create the sum of 100 terms, I add them, then I will get at the end 300. With this way, if we have a big number of terms, we will be short of space. So we need to look for a short representation for this type of addition, which is addition with identical terms. And this is where the sign read times, which is a cross sign read times, was introduced as a short notation of a long sum with identical terms. Short notation with short notation of long sum with identical terms. Of long sum with identical terms. So instead to have, for example, 2 plus 2 plus 2 plus 2 plus 2 5 times, we just write it down as 5 times 2 and I will get 10. Or if I have 3 plus 3 plus 3 plus 3, so what we have here, we have 4, 3, so this means I have 4 times 3, which is 12. So this is the beauty of the multiplication, is it's like what you call like a condensed form of long addition. So it's like I'm talking about multiplication is a condensed form of long addition. So if you can see this way, so this is exactly what it is. Now let's define what is multiplication. So we're going to give a definition of multiplication. So multiplication, in fact, is a process of finding a quantity called product by taking a countable sum of identical addend. It's exactly what is multiplication. So multiplication is a process of finding a quantity. So this quantity is called product. By taking a countable so when we count the terms we call that number multiplier, countable sum of identical terms. The identical terms are called multiplicand. Called multiplicand. So in fact what do we have? We have the product is equal multiplier times multiplicand. Most of the book they don't use those terms anymore, but it's better for you to know those terms. At least in business and in chemistry we use the term multiplier a lot. At least you know what this means, multiplier. So most of the book now they use factor, but it's better that you know those two terms because it will help you in other subjects. And there are many reasons of using the word factor instead of multiplier and multiplicand. And one of the reasons is like when we switch position of the multiplier and the multiplicand, the result always stays the same. So here if I have 3 plus 3 plus 3 plus 3 plus 3, here I will get 12, and if I have here 4 plus 4 plus 4, I will get 12. As you see, the result stay the same. That's mean the product stay the same if I switch position of multiplicand and multiplier. So if we switch and we still have the product the same, so why we keep different names? So this is one of the reasons. But for me, I prefer that always the first terms of multiplication is multiplier. So if you can keep this one in your mind, that will be good. Now the question, how we can apply the definition to multiply any two numbers. To multiply one digit number with another one digit number is straightforward, it's very easy as you see here. And with that idea we create the multiplication table. So but when it's come to 2-digit, 3-digit numbers, so we need another way to multiply those numbers without using the concept of addition. So for example, if I want to multiply 14 times 3, so I'm not going to just write down 340 times. So there must be a way we can multiply without using addition. So in that case, as we know that 14 times 3 is the same thing as 3 times 14, so we can make this as this form, so 3 times 14. And 14, I write it down in the sum of two numbers, which is the distinct quantity. So I'm going to write down in terms of 10 and ones. So this will be 3 times 10 plus 4. Well, look what happened here. We have 3 times that sum. So when we have 3 times that sum, that's what you do, we add that sum 3 times. So here's going to be 10 plus 4 plus 10 plus 4 plus 10 plus 4. So now we can check how many tens I have. I have 1, 2, 3, 3 tens. So it's going to be 3 times 10. Plus how many 4 I have? I have 3. So it's going to be 3 times 4. As you see here, instead to go through these steps, so if I want to go through these steps, what I need to do here, you see I just need to multiply 3 by 10 and 3 by 4. So if I have a number here and we have a sum, I just multiply that number with each terms of the sum. And this concept is called distributive property. So this is exactly what is distributive property. So instead to have this process, so if I have 3 times 10 plus 4, I just time this by this and time this by this. That means I time the number by each term of the addition or whatever version you have here. So we'll see when we can apply, but this is the concept of distribution. So here it's going to be 3 times 10 plus 3 times 4. So this is the idea of distribution property. Let's write the property. So distribution property. So given A, B, C numbers, so we have A times B plus C is the same thing as A times B plus A times C. So the idea of distribution property is you multiply that number with each terms of the addition. So if I have 3 terms here, I multiply that number with each terms of that addition. If I have 4 terms, and so on. So I multiply each terms by that number. So we will see the application with numbers. Let's pick an example. Suppose I want to multiply 215 times 3. So how can I do that using distribution property? So this multiplication is the same thing as if I have 3 times, and I'll write down this one in terms of their place value quantity. So it's going to be 200 plus 10 plus 5. Then what I do here, I distribute that number to each terms of the addition. So here I will have 3 times 200 plus 3 times 10 plus 3 times 5. So here I will have 600 plus 30 plus 15. So when we add, I will end up having 645. And this is the same concept you use when you multiply the number vertically. So we have 215 times 3. So what did you do? You multiply 3 by 5, then you multiply 3 by 1, then you multiply 3 by 2. You see what you do here? You distribute the same idea. So that means the multiplication we use in 2nd, 3rd grade to multiply those type of number is the distribution property. So here I will have 15 because I have 1 10, so I'm going to carry the 10 here. So 3 plus 1 is 4, and here I will have 6. The same thing. That means you are using distribution property, you don't even know it. Another example, just for fun. So suppose I want to multiply 324 times 213. So normally if I multiply this vertically, normally we start with the ones and move to the left, so next tens, next hundred, and so on. So is there any way I can multiply this without using that order? So suppose I want to start with the tens, then move to the ones, or move to the hundred, then do the ones. Is it possible to do that order? So if I don't want to follow the order, like start with the ones, tens, hundred, so is it possible? In fact, with distribution property, it's possible. So, but you need to know the concept behind the way that you multiply here. So keep in mind, when you multiply with the ones, we start the answer from the ones. So when we move to the tens, we start the answer from the tens. When we move to the hundred, we start the answer from the hundred. So that's the idea behind. So if I want to start with the tens here, my answer should start from the tens. If I want to move to the hundred, that means my answer should start from the hundred. If I want to do the ones, so this answer start from the ones. That means you start your answer from the place value of the multiplier. So this is the multiplier. So this digit is the multiplier. So this digit is the multiplier. This digit is the multiplier. That means the place value of that one is 1. So I'll start from the ones. The place value of that one is 10. So I'm going to start from the tens. The place value of that one is 100. So I'm going to start from the 100. So that's the key of the multiplication. Do I have to start from right to left? You don't have to. So if you know how to manage yourself, so you can do it from any place value you want. So if I start from the tens here, I will have 4, 2, 3. So this is going to be 8, 4, 6, and here is going to be 12, 7, 9, and when we add, so I got 2, and this is 11, so carry 1 here, 20, carry 2, so 9, and this is 6. The same thing. So if I do it the way or the order that we do in early age, so I will have here 12. See, I will have that number here, so it's going to be 7, 9. Then I will have this one in the middle, so it's going to be 4, 2, 3. Then I will have this one at the last, which is going to be 8, 4, 6. You see, same idea. So when I add, it's the same thing, the same addition. The only thing is the terms are not in order here. So here's going to be 2, 11, so 0, so here I will have 9, and this is 6. And I will have the same answer. This is all about the lesson today. So I hope you understand the concept behind multiplication, and multiplication is just one of the application of addition. And if you have any comments, please do so. It will help me a lot improve my way of teaching and presenting. So thank you for watching the video, and Assalamu alaikum.